everyone, welcome to Edu Plus Leisure YouTube channel. Meeting you all back again with a video after a very long time. So we had to take a break because of my A-level examinations. I'm from the 2024 batch, and so I'm done with the exams now. So I thought to start a series of video of the chemistry A-level paper discussions in English medium, because when I was studying also I found it very difficult to find discussion for the past papers in English medium in the YouTube channels. Therefore I am going to start English medium past paper discussion for chemistry, and I'll be starting from the 2010 paper and moving forward. And you know, 2010, from 2000 to 2010 there were 60 MCQs in the chemistry paper, but following from 2011 we are having only 50 MCQs. So I'm starting from the 2010 paper, because it's very implying with the new syllabus also. So let's then start with the questions. So our first question: the period in the periodic table that contain the elements found in all three physical states. Now you have to take two periods where you having all three physical states, that is solid, liquid and gas. Now you know, in our periodic table we have almost two liquids, that is the metallic liquid mercury, non-metallic liquid bromine. Solids and gases we can find in almost all periods. So if you take the two periods which has the liquid metals, that will have all three physical states. So here you have the periodic table. You can see bromine is in the 4th period, then mercury is in the 6th period. So period 4 and 6 will have elements in all three physical states. Therefore the answer for the first question is 5th answer. So first 10 are actually very simple, we can go on discussing. Then the second question is, normally we are seeing such a question in every past paper. This is organic naming. So first what we should do is we have to identify the principal functional group. Here we can see there's a carboxylic acid group. Then it should be at the end of the chain now. Then you have to select the carbon chain with the longest carbon chain with the highest number of carbon you have to select. That is the second step. First the principal functional group, and according that you have to select a carbon chain with the highest number of carbon, and you have to start numbering as the principal functional group should get the lowest number. So here 1, 2, 3, 4, 5, 6. So we have 6 in the carbon chain. Then you can see for a second carbon there's a methyl group added. Even for the third carbon a methyl group. These are substituent groups. So those only will be named first. So you have to put there are 2 methyl groups now. 2, 3 dimethyl. Okay, 2, 3 dimethyl. So with that itself you can find the answer is the 4th one. Nevertheless we'll go with it. Dimethyl. And you can see there is a double bond here also here. So 1, 2, 3, 4. 4th carbon is having a double bond. So you have to put 4-hexene. The double bond also should be named 4. Then hexene, ene because it is the double bond. Hex is because there are 6 carbons in the main chain, and oic acid because the principal functional group is carboxylic acid. So this is a very simple thing, organic naming. Easily you can score the marks for this. Okay, so therefore the answer for this is number 4. Second one, answer number 4. Okay, now third one we can see that is a inorganic MCQ. It seems like an inorganic MCQ. Okay, a certain salt dissolves in water and gives a colored solution. So a salt is dissolving in water and it is giving a colored solution. That means now you know a salt is having a cation and an anion. So either the cation or anion has given a color to the solution. Now we don't know. In the options we can see we have only cation. So the cations is only giving that color. When dilute NaOH is added to this solution, a pearl green precipitate is formed. So you know, in the cation analysis we have studied when you put small drops of hydroxide, green precipitates according to these options. Green precipitates we can observe from nickel hydroxide and ferrous hydroxide. Both are green precipitates. Now they are adding ammonium hydroxide is added to the precipitate. It dissolves forming a blue solution. That means the formed hydroxide, okay, the formed hydroxide is forming an amine complex which is blue. That's what it is dissolving. That's what the precipitate dissolving means. It should form a complex and dissolve. So it is forming the amine complex, and we know that nickel amine complex is only blue. Therefore the correct answer for this question will be the second one. So if you have a clear knowledge on all the parts of the inorganic, easily you can take the answer for this. Alright, so I am moving on to the fourth question now. When 100 cubic centimeter of a hydrocarbon was completely burned in 600 cubic centimeter of oxygen, 300 cubic centimeter of carbon dioxide and 400 cubic centimeter of water vapor are formed, the oxygen remained unreacted after the combustion was 100 cubic centimeter. So this is a very interesting question. You have to find the formula of the hydrocarbon. Okay, now let's find it. Okay, let me go to the whiteboard. Now here 100 cubic centimeter of hydrocarbon was completely combusted in 600 cubic centimeter of oxygen. Now the hydrocarbon you have to find, no? So you don't know what is the number of carbon and hydrogen. So you can put X and Y or something. Then it is reacting with oxygen, which is O2. So which will be giving you carbon dioxide and water. Alright. So you had 100 cubic centimeter of this, 600 of this. So what you have to use here is, since this is gases, from the gas laws you know pressure is equal to CRT. Sorry, pressure is equal to PV equals nRT. So when everything is constant here, okay, you can proportionate volume to the moles. Okay, you can proportionate the volume to the moles. So you can take the volume directly as moles and work it like a reaction. You take like a stoichiometric reaction, you can work it. So they say that how many 300 cubic centimeter of carbon dioxide and 400 cubic centimeter of water is forming. Also they say that 100 cubic centimeter of oxygen has remained. 100 cubic centimeter of oxygen has remained. Now this will be completely combusted. Okay, this will be completely combusted. So what has been reacted is 500 cubic centimeter of oxygen has been reacted. That's what 100 has been remained. So 300 formed of carbon dioxide and 400 formed of water. Now you can work it as a simple ratio. So how they reacted is 100 cubic centimeter of the hydrocarbon reacted with 500 cubic centimeter of oxygen. Then it gave you 300 cubic centimeter of carbon dioxide and 400 cubic centimeter of water was formed. So in this ratio only they reacted. So you are automatically getting the stoichiometric ratio. You are getting the stoichiometric ratio. So here it will be 3. Then this is 4. This is 5. So this is 1 means you can see now X you can find. So you can see in the product side you have 3 carbon. Y you can find in the product side you can see there are 8 hydrogens. So C3H8 is the molecular formula of this unknown hydrocarbon. C3H8. So what is the answer? Fourth answer. Fourth one, your answer is fourth one. Okay, fourth question answer is fourth one. So I hope you are clear how you got the answer. So I am marking the answer. It is the fourth one. So this is very simple, like a normal reaction only. You have to work out. You have to take volume proportional to moles. So actually when you are practice with the questions, you won't be proving everything. You know that this is that. So this is a MCQ point also. Many years you can find this pattern. So your answer is the fourth one. Alright. Now fifth one. Identify the molecular ion from those given below whose shape is distinctly different from SO3 2-. So before that, now we should know the shape of the SO3 2-, right? So we'll draw SO3 2-, one O, another oxygen and another oxygen. So I'll put here 1. Now there should be 2 minuses, no? So sulfur can have 6, 1, 2, 3, 4, 5, 6. So here minus, here minus. So the central atom is sulfur and you can see the shape is trigonal pyramidal. So you have 4 VSEPR units. So that is tetrahedral actually, the electron pair geometry. So one has turned into a lone pair, therefore this is trigonal pyramidal. So you should find a shape which is different from it. That means which is not trigonal pyramidal only you have to find, no? Now ClO3- I will draw. Oxygen, oxygen and oxygen. So you can put double bond, 1, 2, 3, 4, 5, 6, 7. So this is minus. So ClO3 minus, you can see that is trigonal pyramidal. PCl3 is also trigonal pyramidal. SOCl2 is also trigonal pyramidal. H3O plus is also trigonal pyramidal. NO3 minus, now if I draw, so you can see there's a plus on nitrogen atom, minus on here and here. So one plus and minus will get cancelled and another minus remains. So this is actually trigonal planar. The shape of NO3 minus is trigonal planar. Therefore, which is distinctly different for SO32 minus is the fifth option. Okay, that is the fifth option. Now let's go to the sixth question. So sixth question is an increasing decreasing order question. That is also a very important pattern in the chemistry level paper. Lot of increasing decreasing orders are there, like boiling point, melting point, the stability, then acidity, basicity, lot are there. Okay, now let's see the next question. The increasing order in the rate of the reaction of the compound A, B and C when taking part electrophilic substitution reaction. Now electrophilic substitution reaction means electrophiles should come and attack. Electrophiles are actually positive species. Now positive species should come and attack. Positive species will easily get substituted if the benzene ring is rich in electrons. So you have to find which are the components which are making the benzene ring electron rich. Now you can see A has nothing, so that's a normal benzene ring. B is having a chlorine. Now you know chlorine are orthopara directors, but they are deactivators. They are deactivating the benzene ring. So the electron rich is becoming even reduced in the B1. When you take C and D also you have orthopara directors only, but C is a strong orthopara director because oxygen atom is directly connected to the carbon, then it is a strong activator. So that benzene ring is very electron rich. D, if you take, it is having a methyl group. It is also an activator, but it is a weak activator. So the highest one will be C. Okay, the highest one will be C. Next highest will be the D. Okay, next it will be the A, because now B has even deactivated now, so B should be the lowest rate of reaction. Therefore, according to this, C is greater than D, D greater than A greater than B. Therefore, the answer is fourth one. So here you have to see the benzene ring is whether electron rich or not. If the benzene ring is more electron rich, then that means that rate of reaction is faster. So benzene ring is becoming electron rich by the activators. Okay, by the activators, and among that also OH is a strong activator. Therefore, that C is the highest one. B is the lowest because B has a deactivator, that is making the benzene ring less electron rich. Therefore, our answer is the fourth one. Now I am going to the seventh one. Seventh one, they have given a few compounds. Let's see what is the question they are asking for. The increasing order of the solubility of the above compounds in water. Now they are asking the solubility of the compounds. Now solubility, if you take polar components, they only will be well dissolved in water. So when you take and also which are forming hydrogen bonds with water, okay, which are forming hydrogen bonds with water only will be forming which is greater solubility in water. So alcohol is having a very high solubility, even greater than aldehydes, you know that. So therefore now there are two alcohols, B and N. Alcohol is the highest solubility. Now when you consider two alcohols, alcohol is the lesser number of carbons, okay, lesser number of the nonpolar group only will have higher solubility, because when this nonpolar group is becoming larger and larger, the solubility is gradually decreasing. Therefore B is the highest. Next it will be the A1. So next, if you take, you have to take another polar compound, that is the aldehyde. So aldehyde can form hydrogen bonds with water, but not with itself. Okay, it can form hydrogen bonds with water. It is a polar compound, so that's also well soluble in water. Next to alcohol it comes, and D is the lowest. Okay, D is the lowest because it doesn't form any hydrogen bond with water. Therefore, its solubility will be less. So this should be the order. So according to that, the answer will be B, A, C, D, right? Second one is the answer. Alright. Okay, now we are going for the 8th question. An aqueous solution of calcium nitrate contains 20 mg of calcium 2 plus ions in 0.5 decimeter cube. The concentration of NO3 minus in the solution. So you have 20 milligram of calcium 2 plus ions in 0.5 decimeter cube. First we'll find the moles of calcium 2 plus. That's better. Okay, if you find the moles of calcium 2 plus, then you can find the moles of NO3 minus. After that you can divide by the volume and take the concentration. So you have 20 milligram of calcium, no? So we'll find the moles. So 20 milligram, 20 into 10 to the power minus 3, or molar mass of calcium will be 40. So here 1 and here 2, so that is 0.5 into 10 to the power minus 3 moles. So calcium moles is that much, means the compound calcium nitrate is also 0.5 into 10 to the power minus 3 moles, but you can see calcium nitrate, calcium to nitrate ratio is 1:2. Therefore nitrate, the moles of nitrate will be the double of that, that is 1 into 10 to the power minus 3. 1 into 10 to the power minus 3. Now you have to find the concentration. Concentration is moles over volume, and you know the volume they have given in 0.5 decimeter cube. Okay, they have given in 0.5 decimeter cube. Then the answer will be how much? 1 divided by 5 is 0.2. Then 0.2 into 10 to the power minus 2, right? Let's see. 0.2 into 10 to the power minus 2 means it will be 2 into 10 to the power minus 3. Answer is the third one. 8th question answer is third one. Alright. So it's very simple. You find the moles and then you are finding the concentration. There's nothing big difficulty in that. Alright. So answer is the third one. Which molecular ion, now 9th question, which molecular ion from those given below has the highest dipole moment? Highest dipole moment, if you take, they should not be like, they should be polar compounds definitely. Now ICl4 minus, if you take, it is a square planar compound with identical terminal atom. It is a non-polar compound. Dipole moment is 0. Alright. Then AlCl3 is a trigonal polar molecule with identical terminal atoms. That is also dipole moment is 0. Now here they have given NO2 plus. NO2 plus if you take, that is also, it's a compound like this, no? NO2 plus. NO2 plus. So this is a linear atom with identical terminal atoms. So that is also dipole moment is 0. O3 also the dipole moment is like not 0, but it is having a very less dipole moment due to its shape. Its shape is like this. O3 will be like this, here minus and here plus. So its shape is actually angular in shape, but it is having identical terminal atom, therefore dipole moment is less but not 0. So ammonia is having a very high dipole moment, therefore 9th question answer is the third one. So you know, if there is a molecule with identical terminal atoms, okay, in the shapes of linear, trigonal planar, tetrahedral, square planar, then octahedral and trigonal bipyramidal, those dipole moment is 0. Others, other shapes, okay, other shapes there is a dipole moment. So with that you can determine the strength of the dipole moment. So answer is the second one for that. 9th answer is second one. The increasing order of the boiling points of the compound. So first, for the boiling point you have to see is the first criteria is interaction. Okay, interaction is the first criteria. So in that you can see carbon dioxide is London force, sulfur dioxide is what? That is the only polar compound which is having dipole-dipole interaction, and all are having London force. Therefore sulfur dioxide should be the highest. So you can reject third and the fifth answer. Then you can see you can see all the rest of the ones are having, all are having London forces. Then you have to go with the molar mass. So carbon dioxide it is 44, nitrogen 28, helium it is 2, neon it will be like around 14 or something, I cannot remember properly, definitely not greater than 28 or 44. Therefore you can see higher the molar mass, higher the boiling point. So therefore sulfur dioxide next, it should be carbon dioxide, then nitrogen dioxide, then neon, then helium. Therefore the 10th question answer will be the number 1. Okay, number 1 is the answer.